Well, another day, another Zoe. The good news is it's not raining. So what we've got here is a 2013, as you can see, 5 AM. So this is the Continental style motor with the BCB on the top. So the 5AQ, which is the Renault designed motor, has got the fan housing here. So this is a 5 AM, nice and early one. So this starts and drives, but does not charge. Customer said intermittent charging. I haven't managed to get it to charge at all. I'll show you what it does. I've got my grey cable here. And I should say, if you're not subscribed, please do so, because I'm getting sort of close. Oh, it's gone to sleep. Hold on, caller. I'm getting... That is interesting, actually, because it would normally wake up. Ooh, interesting. And if I just unlock it and wake it up, there we go. Can you hear that? That's the charge plug lock going in and out. That's not normal. So normally, as I would just lock in and stay locked in, and then try and charge. You don't normally lock and unlock. Yeah, that is weird. Eventually it goes to battery charge impossible, which is your classic. I can't charge. By the way, battery charge impossible doesn't mean impossible. It means failed. It means the last attempt to charge failed. Okay, so that goes in and out and in and out and stops. Interesting that the car didn't wake up, and we've gone red. So there we go. So I'm just going to unlock this. I should say thank you to Kevin for sending me this car. So this was at Renault. So obviously had some charging issues. Went to Renault. Renault said, and I think you're going to like this, they said there is an issue behind the dash and they need to take the dash out. Well, that, I think, I've heard a few weird things, and that's pretty weird. And they sort of have started taking the dash out. Anyway, so I did some basic checks on this car, because the first thing I do is I don't just plug it in, basically. Obviously, that might not be safe. There might be a dead short on it or whatever. So I did some basic checks, diagnostic checks, and also insulation tests. And the insulation, which is the sort of resistance between the high voltage system and chassis ground, is quite poor on this car. And there's a special way you measure it with an insulation test meter, and that meter actually generates high voltage. So it's the resistance, but with a good amount of voltage behind it to push through. So that's poor. Okay, so we know that. Little tip, that's nothing to do with the wiring behind the dash. So having now sort of plugged it in and seen the lock popping in or out, we could have an issue with the socket, with the solenoid lock, whatever, with the wiring, who knows. So we're going to rule that out first of all, because it's easy to do, and we're going to just swap the socket over. So I've got a spare one there. I actually just had to repair that one because it's just an old failed one, but I kind of keep a few for spares. Depends what the issues with them are, but that was a repairable failure. So that's now my spare one. So I'm just going to pop that on, and then we'll see what happens. And obviously that will just rule that bit out. So I'll be back in a mo. Well, I haven't yet even swapped it over, and I'm back already. So first thing is, we've got an overheated pin here. So this is the neutral. So if we go down here as well, I'm going to go wonky so you can get down there. If we look in there, look at that, lovely. Very nice. Yeah, so we've got an issue there. Whether that is the issue that's stopping it from charging, it may be or it may not be, but I'm going to continue to fit this socket just to see if we can get a decent connection, because obviously if we've got one good side and one cooked side, then yeah, we may still be able to get it to charge. That might be the fault, or it might be a fault. We shall see. Back in a mo. Right, so I got this socket connected. There's a bit of an issue with the locking configuration on that socket, but for testing purposes it's fine. We're not testing that, we're just seeing if it charges and if there's an issue with the other socket. So ooh, red straight away, didn't like that. So what have we got? Battery charging possible straight away? We have that. Well, that's interesting, because it's different to how it was before. Right, let's just disconnect that. I am going to go and get my this is really hard with one hand. Going to go and get my diagnostic machine and just get an update on what we've got. We've got battery charging possible there. I suspect that this has come out, because that needs to be shoved all the way in, and it's currently not being pulled in. Yeah, that's probably what's happened. My socket is not fitting closely enough. I think I should probably just repair this, and then that'll all go properly on, and then that'll be a proper test. Right, I'll be back. Right, so previously when we plugged it in a minute ago, it just went red straight away. If you've had any issues with your Zoe not charging, you've probably kind of learned they get stuck in this mode where they sort of like have a bit of a hissy fit. It's like, oh, I couldn't charge, so now I'm just not going to try, which is kind of annoying when you're trying to diagnose them. Obviously, if you've got a diagnostic machine, you can kind of reset the errors. I've just left it for a few minutes and come back. But that's quite a common thing known on the sort of Zoe groups and stuff. You lock your car, leave it, let it fully go to sleep, and then kind of come back to it. But so that's effectively what we've done. So now we're just going to give this another go. So now it's not cycling the lock, which is a distinct improvement. Okay, so it's made some clicks. We're doing ongoing checks. There's half a chance that might actually charge now. Ooh, maybe not. Has this turned on the power? I think the cable's turned on the power. Oh, it's configuring. Now it's charging. Okay. Cool. So we're just going to let that charge for a minute and see what happens. So, it looks like what we've got here, the original fault, is probably the locking, either the locking connector or the comms. So the car was cycling the pin in and out. So that either means that the locking pin is not working properly, so it's being told to lock, but for some reason it's popping out again because of a fault with that like locking solenoid, or the car is not receiving the message from the socket that it has locked. So maybe the solenoid is locked, but the position is not reported back to the car or something. The car thinks it's not locked, so it's kind of like unlock, lock, you know, it's like have another go, lock, lock, and the socket is telling it, no, it's not locked, it's not locked, kind of thing, something like that. But okay, we're getting somewhere. We're obviously not out of the woods because that pin is burning out. I'm obviously using the granny cable, and that is low amps, which is good, but we are putting 10 amps through that pin, which is not ideal, but it's going to need replacing anyway, so, and I'm using a test socket, it doesn't matter. The other issue we've got, obviously, is this car has low insulation resistance, so that still needs investigating. So what we're looking at on this car is the socket seems to have a fault, which is kind of irrespective because it's slightly burnt out at the other end because it's overheated, because that pin's no good. We've got a burnt pin on this, what they call the filter unit, and then we've also got the low insulation resistance, so that needs investigating as well. It's not it's not terrible, but it's something that definitely needs investigating, and if something can be fixed fairly easily, do it, or might just have to say to the customer, you know, the car does charge, there's an issue brewing in X, you know, in another area of the car, which obviously will narrow it down so we can tell the customer where that is and find out the options and things. But it might be something that's really expensive to fix, it's an older car, and it might be the case of now it works, now it charges, you know, and it can go until that other brewing problem becomes a major issue, if you see what I mean. But yeah, we can get it back on the road. So Renault, the issue is behind the dash, is it? Yeah, I don't think it is. Right, well, I'm just going to talk to the customer, let them know what we found, and yeah, go from there. But yeah, kind of interesting. So we're not quite out of the woods yet. We do need to investigate that low insulation resistance. Obviously, I need to let this charge for a little bit because it was literally on 0%, and it will probably be on 0% for a while, because it was on limited performance, so it kind of was below 0%. It's done 80k, which is pretty good for one of these, to be fair. So the annoying thing is I'm gonna have to put all that blooming dash back together. Really annoying. Anyway, so yeah, okay, cool. At least it's charging now. So 99% chance there's an issue with the socket somewhere with that lock or the wiring. There's definitely a burnt pin at that end. Yeah, and it is now charging. Let's just have a look at what's going on here. Hopefully this isn't all just flash, but yeah, it's consuming 8.99 amps, 2 kilowatts. taking on 0.1 kilowatt hours. Amazing. Yeah, cool. Right, I'm just gonna let that charge for a bit. That can get some juice on board, and then yeah, we will go from there. Right, catch you in a bit. Okay, so we've just clocked over, if I can get it to actually show you, a 1 kilowatt hour. I quite like this charger. This is one of the Screwfix type ones, because it shows you the voltage, the amps and kilowatt hours, which is quite cool for diagnostical purposes. So yeah, we're on 2%. So that is charging. It's a bit, it's got a bit damp in there. Once it's got some juice, we can put the heater on. But yeah, it's charging absolutely fine. So I want to get a bit of, get a decent bit of charge into it, get it to 10% or something, just so that if this is a complete fluke and we can't get it to charge again, we've got something in it. The battery's in a slightly healthier state. It's easier to move around. It's not going to keel over. When they get really low, they stop charging the 12-volt battery and stuff like that, and then it kind of just like everything gets a bit more difficult. So yeah, this is good. And then yeah, we can then investigate that low insulation resistance. I'm just looking up there, because probably what I'm going to do is remove all this scuttle area, and then use all the connectors at the back of this BCB to do some further testing. So this is kind of like a junction box, but also it does some of the charging. So it does like some checks, and it's got a rectifier in it and stuff, but it's not the whole onboard charger. The Zoes have a bit of a weird charging setup, which you probably know about if you've watched a few videos. But yeah, so it's kind of a junction box, high voltage junction box, and some of the charging system. So, and there's a metal cover there, you can just see the bolts. If I take that cover off, there's a load of high voltage cabling there, and I can use that as a test point. So effectively what I'm doing is disconnecting different components from the junction box. So it's like splitting the high voltage system into several different parts, and I can test each of those parts, and then that's how you narrow down where that poor insulation reading is coming from, basically. So I can test up the cable to the battery, because maybe there's moisture in the connector on the front of the battery, for example, and that's causing a slight short to ground. I can test, obviously it rules out this box, so I can test this box with nothing plugged into it. So we'll see if it's within there. I can test the connector that goes down to the motor controller, and then that's connected to the motor. So if you get it on that leg, you're then motor controller and motor. So then we take that box out and investigate it further. So I have seen this issue inside the motor controllers before. So, but yeah, we'll see. Could just be moisture in a connector. Could be something else. But yeah, we kind of want to cover all the bases really. I'd never like to give a car back that's not that's got, you know, potentially going to have another issue. Basically, you want it to be reliable as much as you can for the customer, and I tend to have a good success rate with that, which is good. So, and I think that's why people kind of bring them to me. Really, we get to the source of the fault, investigate anything that needs investigating. So yeah, I can start stripping that scuttle off while it's charging. And then we'll get that cover off and connectors and stuff. Obviously we have to do high voltage shutdown. We're not going to do it when it's charging, obviously. Yeah, high voltage lockout, just yeah, make sure it's obviously safe. Do our high voltage tests so that we know we're safely working on the high voltage system, and then we can do the do those tests with the insulation test meter on each different section of the high voltage system once it's separated out. Yeah, those connectors are always good fun, because they've obviously not been undone. Maybe they've not been undone in 13 years or whatever since this car was made, and they're obviously backwards as well, in your sort of arm's length, doing them in reverse. So it's always a little bit of fun, but once you've done them a few times, it's not too bad. But yeah, well, we'll let that do its thing. I'm really glad it's still charging, and yeah, we'll see what happens. All right, cheers. Well, I got slightly distracted by a truck arriving with a Zoe on the back of it. So this is on about 20%, but I've just unplugged it, and I'm just going to plug it back in again, just to make sure it starts charging again, just to see that, you know, 2 out of 2 tries of what happens, basically, just to see if it seems like we've got reliable charging at this point. We heard that click, that's the car configuring for single phase, and it sings when it's winning. So that is all good. Just have a look at the dash, yeah, 21%. So that's in a bit of a better state than it was. So that's cool. So I'm going to unplug that in a second. So I've got this scuttle off. So here is the cables we want to access. So I did a test already on this one, which is a supply to the air conditioning compressor. That's very common for a short. It's not that. Obviously this one just is the AC incoming that comes from my, just ready to see where it comes from now. That comes from my charging socket. So there, we don't need to worry about that one. Oops. And yeah, don't need to worry about that one, and I've done that one. So over the back here, that's the supply from the high voltage battery. That's not used. That's an extra connector for a high voltage heater for like really cold countries like Norway and stuff. Not used in the UK, so that's got a blanking plug on it. That's the DC power out to the motor, and that is an additional connector for the motor. It connects to the center point of the winding on the motor for charging purposes. But anyway, yeah, that goes down to the motor basically. So yeah, we want to test those 3 cables. So what I'm going to do is disconnect this in a second, do my 12 volt lockout, high voltage lockout, do some tests, and then we'll just to make sure it's safe. And then yeah, we will test down those cables and see where the yeah, see where it goes basically, see where the fault is coming from. Right, catch you in a bit. Well, that didn't take very long. So with all these connectors on the back, the accessibility can be a bit fun and games. But if you just imagine inside this box, all the positives are connected together and all the negatives are connected together. Okay, that one's a bit different because that's a single wire for a specific purpose. So just ignore that one for a second. So we've got a connector here, which is the high voltage power to the air conditioning compressor. And so I've got a positive and negative. So I can connect to the positive, and that positive is connected via this box to the battery. Okay, the battery relays are turned off, but we're going down the wire and into the battery case. So it's connected to the battery, which is switched off. But I'm connected to the motor controller, which is connected to the motor. So I can sort of test everything through this. And then what I can do in turn is just remove each of these, and when the reading changes, you've found the culprit. It's really quite complicated. Yeah, what I did was I started at that end, I've disconnected that one, and now I've got a reading of 500, which is perfect. So it takes a second to settle down, but I've got 500, which is fantastic. Now if I reconnect this one, which is the battery, and I do another test, we've now got 1.07, 1.08, which is very poor. So yeah, that basically narrows that down. So no point investigating anything else under the bonnet. We now move to investigating the battery. So what we need to do is have a look at the other end of that cable. So that cable runs down to the front of the battery, and yeah, there's a couple of under trays and things like that. What we need to do is get the car lifted up, inspect the front of the battery, and see if there's anything going on there. We could have a damaged connector, we could have a frayed cable. The cables have like a shielding on. It's hard to kind of see really, but yeah, like an earth layer around the outside, which tends to be connected kind of like to these shielding parts. And nice bit of wind. So if you get a frayed cable, the car notices basically because it sees the insulation issue. So yeah, it's towards the battery basically, whether it's that cable or the actual, could be actually inside the battery, because the that connector basically goes down to the battery, then it goes inside the battery, and then the main relays are inside the battery case. So let's say we had, I don't know, moisture inside the battery or something, that would cause that. Or yeah, damage to the cable, moisture in the cable, anything like that. So we can investigate the battery. So I kind of like these jobs because you literally don't know which way it's going to go, and then you're like, oh, okay, it's going that way. So and then you're thinking on your feet, which is a lot more interesting than just doing a job you've done 10 times before, basically. So yeah, so that's quite cool, really. So let's have a little look down here. It's literally easier for me to look through the camera. Sorry, just get that wiggled. So looking at that one, yeah, you can see that shielding. We can see the cable down there. Just get that to focus. Yeah, so that all looks fine. There's nothing wet there. I'll just take that connector off and look inside it as well. It's difficult to do with one hand. Hold on. Right, I've got that connector off. Yeah, there's nothing to see. So yeah, we're looking for any damage, moisture, burning, anything that shouldn't be there, basically. But just a dry connector that looks like how it came out of the factory is obviously good. So what I will do is I will just put my meter directly in here, just as a sort of double check. But yeah, obviously we're getting a bad reading there. It's obviously it's also useful to actually do each one, because we're at the battery, we haven't just got
a single component at the other end, like the motor on the air conditioning compressor, we've got a battery circuit, and so it may give us an indication as to what's happened if we get a different reading or the same reading. Basically, it's all just little clues pointing us towards what it could be, and then we need to find something. And we might see that everything looks perfect. We can actually do some tests inside the battery through the service plug hole, which you have to be extremely careful doing, but can also give us an indication of what's going on inside the battery. But yeah, it looks like there may well be an issue. Well, there's an issue towards the battery, could be inside the battery, but we will see what we can find. All right, cool.
Okay, I think I know what this is, and it's not a major issue. So I'm going to try and explain this without it making no sense, basically. But Zoe batteries have a little bit of a feature, and it's probably related to the way they do the insulation testing, because the car is constantly monitoring the live insulation. Let's just turn that off. So you can get low readings from the battery, basically. It varies a little bit between generations of Zoes, so a little bit more prominent on these older ones, which is why it appears to stand out. But then when you trace it back, you're like, okay, no, this is just going inside the battery. So there's, as far as I can see, no issues with connectors, cables or anything, so that all looks fine, which is good, basically. So it's good to rule that out. And I think this is just the way that battery is doing that measurement. So doing sort of isolating it in certain places and doing more tests, it's all just kind of coming back to that sort of like oddity inside the Zoe battery. So I don't think it's got moisture or anything in it. It only goes down one side and not the other, so it's not like the cells have got an issue or anything like that. Yeah, I think it's just that oddity of how the Zoes do the insulation testing, which is good, because it does means no more faffing about on that one. So I think we can kind of rule that one out, basically. And what this car's going to come down to is the actual fault was the socket, probably locking solenoid failure. But we also need to replace that filter unit. So I will let the customer know the costs, basically. Insulation has been ruled out. Yeah, I think part of what we were getting is the cumulative effect of parallel resistances. So it's a bit of a weird one in that you have certain figures that are good or bad, but if you have let's say in this high voltage system we've got 5 things all connected in parallel, well, they each have a resistance, and the more you add, the overall resistance goes down, because it's like having lock gates. They have a really high resistance, right? They really, you know, keep a lot of water back. But then you have a weir, and then a little bit of water might flow round or above the lock when it's too high, but the water also flows over the weir, so you've got 2 places for it to go. So you know, it's only half as difficult. It's twice as easy for the water to flow down. And it's the same with resistances. The more things you add in parallel, that reading is going to go down. So we've got a little bit of effect of how the battery does the measuring, and a little bit on parallel resistances on a car that's 13 years old. So it's not going to be perfect. And then when you add up all those parallel resistances, you're getting kind of like borderline figures, but actually when you dig down into it, each one is okay. The only one that's, you know, sort of giving you a worrying reading is the battery, and that's the way it does its resistance testing, basically. So kind of a Zoe quirk, but it's good to investigate. We got to the end of that, and that is cool. We don't have to take too much more apart, but I'm going to have to get this box out to swap that over. I'm just going to go and check my stocks of that unit. I need to get the part number off it and just check for compatibility and stuff. I want to find a date on this unit to see if it's been replaced, because then 06/16, so it is later. So that has been replaced at some point. There's an upside down date there, 13/06/16. So yeah, that has actually been replaced at some point in the past, because this is a 63 car. But yeah, the part number is over there. So 751R, which you can't see because it's not focusing. But yeah, you might in a second. There you go, yeah. So I just need to go look at my stocks, see what I've got, and hopefully, if I've got one, I've got a couple of those. So hopefully I've got a compatible one. Get that swapped over for the customer and get that all back together. So there you go, and then another one will bite the dust. So that is cool. It's all good. Obviously nothing to do with the dash. just complete nonsense from Renault again. But there we go. Hope that was interesting. Yeah, so I'll get that swapped over and it will be all good. And another one bites the dust. And I've got plenty more outside, so I need to get through them. So there we go. All right, well, thank you for watching, and I'll catch you later. Cheers.